help on. So 714. And guys, notice that in 45, there are two different methods they show. Right, one is the percent off method of find the percent off and then take it away. The other is the percent on method, where we figure out what percent is on and solve that. What's up? A couple of you are ready. That's why I had it sitting here to come back to, and we hand that to Lucas. Yeah. Don't turn in your homework before we check it. So Lucas, you're going to turn that back to me after we check the answers, because I did not put a check on it yet. Same with 715, Lucas. But don't turn something ahead of time, because you want to check it, make sure it's good. I'll probably try to pass out papers as we go through class. So yeah, I know, lunch count. Except the internet's down. Email isn't working. So unless you got it sent to me on my phone, and then I can use my phone for that. Mini corn dog. No, wait. Corn dog mac and cheese. Not mini corn dog. Corn dog mac and cheese. Alright, so corn dog mac and cheese. How many people for corn dog mac and cheese? Hands high. Chicken patty, regular chicken patty. Far is that hand up? No. No regular chicken patty. Spicy chicken patty. 1. Cheese pizza. 2. Pepperoni pizza. Just 2. Sun butter and jelly.
Could you add one for pepperoni?
Sorry. Let's focus to get the answers.
Alright, any other additions or changes? You want to make a guess at what she wants?
Oh, yeah.
I can send this in a minute. Just somebody remind me once Layla's back.
I need to get, or can I add the pizza instead of
Cheese or pepperoni?
pepperoni?
Okay. Questions? Some of you, I don't know if I put a see me or if I just put a note on it, but when we made histograms last week, some of you need to watch out with where your bins are, that the numbers that split our bins go right at that split. They do not go between. Our frequency always starts at 0, goes up from there. Any questions? And I zoomed out so we can see a little bit more of these bottom ones. Guys, 750, that's like checkpoint at this point, which really checkpoint for CPM means this should be mastered by now. So combining like terms, being careful with the positive and the negatives. Again, you need to have tried this on your own. You should not just be writing down answers right now. I don't care if you like copy answers on word, but you got to try it on your own. Layla, do you want corn dog, mac and cheese, regular chicken patty, spicy chicken, cheese pizza, pepperoni pizza, or sun butter? Boom. Sent. All right, no questions? Sorry, Layla, you did miss some time on checking homework, but it's in the video. So if you want to go back to the video, you know, the answers will just be right there. It is funny that sometimes I can tell that kids went to look for the answers, which is not a bad thing, but like my videos don't normally get views. If so, it's like 1 or 2. Sometimes we're like, oh, 8 views on a video? Kids must have gone to look at answers. Which is fine. It means that you're trying. You're putting effort into it. All right, so today we are going to talk about percent increase. So I'm trying to make this as big as we can. Percent increase or decrease, what we can also call percent change. So notice that I made my title. If you want to throw a title on your graph paper or wherever, we're talking about percent change The only things that should be out on your desk now are 717 and the math notes packet. Let's look at the math notes packet real quick, and then we can put that away. Yeah, if 714 is done, turn it in. Thank you for checking, or making me slow down. Yes. Did I what? Yeah, and I put them in there should be more in the bin, or in the, whatever you call that container. Can? I don't know. All right, in your math notes packet, we're flipping past our quartile and interquartile range section to the back page. This is what we're talking about today. Percent increase or percent decrease. So we don't really need to review what's in the math notes right now. I just wanted you to put eyes on the fact that it is here. It has example problems for you. I would keep this out while we're going through today's lesson. I would keep this out because it has some advice on how to solve these problems. So if you get stuck, look at the math notes. All right, anyone feel like reading our 76? It's on your papers. You don't have to read it from the board. It's on our paper. We're going to start with 76. John, you want to read the paragraph over here before we get to the letter?
Several years ago, Joe started a lawn care business, Joe Mo's. Due to rising costs, he needs to increase his prices. He is concerned, however, because he has heard that if he raises his rates more than 33%, he might lose business. At the right is a letter he sent to his clients.
So let's read the letter, and then we can pop back over to the below.
After several years of business, MoCare is increasing its price for lawn service.
So that's my fault that I accidentally typed in Joe Mo's because I thought that was funny. But then in the letter, their name is actually MoCare. We're talking about the same company. Okay, so keep reading, John.
Since the cost of gas and other supplies has increased, we need to raise our prices. Our prices will increase from $12.50 per hour to $15 per hour. We hope you continue to be happy with the quality of our work. Sincerely, what in the world? Oh, okay.
Sincerely, Joe. But all right. So, $12.50, right? $12.50. This is what the price was. The new price is going to be $15. So how could I get to 15 if I'm at $12.50 right now? Do I need to go up or down? I need to go up, so I need to add like $2.50, right? But we're not talking about how much do we add here. We're talking about percent change. So I want you and your team to look at these two different methods down here and see if you can solve both of these for the unknown pieces. So here we're trying to figure out what x is. Here we're trying to fill in all of the unknown parts. So up here could be money. We can also write in the middle of here for amount of money. So I'm going to actually help you with that real quick because I feel like this diagram should have had a gap in the middle of this. So right up here, let's go ahead and label the $12.50 that Joe has been charging. What did they say?
Any interruption, can Grant Burrier come to the Perry office? Grant Burrier. Thank you.
What did they say the new price was going to be? $15. And what increase does that take to get from $12.50 to $15? $2.50. So go ahead and work with your team. These are two separate ways that we can solve this, right? So I would look at one and then look at the other. I'm going to try to give you at least 2 minutes, probably more. Have at it. got to start bringing your own pencils. I'm down to like my last couple to give away. And that's a colored pencil. That doesn't work. Well, it works. All right. We should probably use random cards to be fair. Hey, don't let me end class without passing papers out. Alright, so Farah, can you tell me if you want to help me with the diagram on the left or the equation on the right? Or, you know, you can always pass, but... The equation, alright, so we have 12.50x equals 15. What do you want to do here to get x by itself? Yeah! Divide by 12.5, and since I do it over here, where else do I have to do it? To the other side. So if you didn't get to this one yet, go ahead and write in this work here. This is going to make us a giant 1. So we just get 1x, and we know we don't have to label the 1. And throw this in a calculator, I'm going to get a number bigger than 1. 1.2. And we know that that's the decimal form. Look at your math notes real quick. So the amount of increase or decrease is the percent change times the original amount. They tell us here in this equation that they gave us. I would maybe like, that's one important equation. And then down here, it goes through, if they solve for x in this situation. Now, this is switched left side, right side. But this x that we're looking at, that's going to be our percent, but it's not in percent form right now. So 1.20, how do I put that into percent form? Times it by 100, and this becomes 120%. Farah, you want to keep going, or am I going to move on to the next card? Carmen, can you tell me what this is telling me, or can you help me with any of this? Get shuffle back in. John, let's go ahead and look at the diagram before we come back and analyze what this means. Tell me what I can fill in on the diagram.
So what I did is I took the 12.5 and I divided it by 10 to get the 10%.
Okay, so you're adding to this diagram, and you would have had like 1.25
And
was 10%. Now this is interesting because I feel like you're doing more than they needed us to do, but that's okay.
and then if you multiply the 1.25 times 2, you get 2.5
So John figures out 2.5
equals 20%.
is 20%. Because it's money, I'm going to put a second decimal place.
And see, the 2.5 on the very right, the blue number, is also 20%.
So right down here, John is saying if he figured out that 20% is 2.5, then 2.5 compared to the original number we were working with, this is an additional 20%.
Which means that the percent next to it is 80, since 80, 20, 100.
Now be careful. Remember, 1250 was our original 100%.
Yeah, but I'm saying like out of the...
Nah, so here, hold up. Back yourself up. You everything else was right, but this is not 80%. Because we are going past 100%. This is why I have this money here, guys. So this is 100%. This is what Joe has been charging. It is the full price. Sometimes you have a sale where you get to take some of this away, but Joe's going to increase the price, and we're going to go beyond 100% that we kind of see over here in the equation. This is our 100%, meaning
The bottom one's 120.
this, the whole new amount is 120%. Which means, what did we increase by? 20%, because we went 20% past the original. So you need to make a note here that we increased by 20%. And according to the setup in the problem, they said we want to make sure we don't increase our rates by more than 33%. Are they safe? Is 20% less than 33? Yeah. So Joe only increased those rates by 20%. This is still safe. We're still good. Questions? Are you wanting to read for us, or you can if you want? Go ahead. Paige needs your help.
She wants to convince her grandmother to let her sign up for a rock climbing class. The cost normally costs $50, but the school is offering a special price of $34. Paige's grandmother wants to know what percent of the cost of the class she would save.
Would this sort of situation be a percent increase or percent decrease if the normal is 50 and today it's only 34? Decrease, right? We're going down. Now, I don't have $50 to lay on the table in front of you, but you can imagine we've got some amount and then we take some money away. That's a decrease. So, guys, on your graph paper is probably going to be the best place to do this. Let's draw this out with like one of our percent diagrams. But we're going to start at 100% and then decrease some. This is kind of like when we were doing the sale prices last week. Now, you could try to fit this in down here. That's up to you. I'm probably going to grab a piece of graph paper. Go ahead and try to model it out. I want to try to give you guys a few minutes. So I'm going to flip my timer and try to be honest. Ooh, I need to restock the graph paper over here. I will also make you guys more baby graph paper over there. Now, I'm going to be all particular since I'm using graph paper. I'm going to count out 10 boxes to be my 100%. If $50 is 100%, could I figure out 10% just to like have a reference point?
It's $5.
All right, 10% would be $5. Because if we divide by 10. So guys, I'm not making this up. I was grading papers on the way back from our little trip that we took this weekend. And it was my wife, myself, and my other friend in our car who's also a teacher. And I was saying, Dave, I am so proud of my students when I see them use the 10% rule. And so many of you are making little notes on your paper and everything of just saying, like, 10% would be whatever. I like, this is just such a good reference point. Like, it makes me really happy when I see you guys using that because it helps us think through. And I can now use my graph paper to say, okay, if each of these is $5 and I want to get down to 34, I know my $34 would be like right here, essentially. Chat with each other if you haven't. I know I've been talking. I'm going to be quiet for a couple minutes. Try to calculate what percent either she saved or what percent she is paying now. Because we'll talk about both. bet you can figure out what percent $1 is. There's no work. I mean, there's some things written down, but where's the work? Can you write out some work to justify it? 'Cause I'm telling you, you're wrong. Write out some other relations, like what I have written. Okay, then fix your math. This is not correct. Show me proportionally how we get there. We can keep talking if you want to, but don't mumble stuff under your breath. Be bold enough to at least say it. If $5 is 10%. Actually, dudes, I might have to pull back. Am I telling you that was incorrect? So I'm thinking of the next problem. If $5 is 10%, and I'm way off my game today because we lost the internet and everything is. Actually, let's check on that. Maybe. Let's see what happens. Alright, so I always say I will admit when I am wrong. My brain was mixing up labels, and this is why I really want you guys to be writing things down with labels. If you do not have some extra notes written, it's probably too small to fit stuff in right here. So if $5 is 10%, what would then $1 be? $1. See, this is why we gotta have labels, guys. $1 would be what percent? How would we go from 5 to 1? Divide. Guys, this is freaking me out. Because we were doing this last week. Hey, if you're talking or goofing around, I don't know why we're cutting paper. Like, I need your eyes up here. When we set up this proportion, this came from $50 was 100%. We divided by 10, and got 10%. Then, what do we do to go from $5 to $1? Divide by 5. Guys, if you don't have this on your paper, or if you were struggling to tell me what we were doing, please write out the work. So that gets 2%. Now, John, I will still say your answer was off, but this that you told me was right. So my bad, dude. So then, if you want to talk about 1%, what is every single percent? 50 cents, but we're not really, like, we don't really use 50 cents much in this problem, or like maybe really at all in this problem. So I don't know if I would go all the way to here, but we can figure out that every $1 would be 2%. And I think that is valuable information. Because if every $5 is 10%, what would $15 be? How would I go from 5 to 15? Times 3, so this would become 30%. And then, how much do they actually save? $16. So I would have my 30% and another 2% telling me all. Now, some of you are like, well, I'm lost. That is why we're going to look at this other technique. So we're going to take the original amount that was 100% and multiply by some percent. I want you to, no matter what work you've done, draw a squiggly line or something and set up 50 times x equals, what's our new price? What's the new price of climbing classes, or the sale price? 34. So the original price, the original 100%, times a percent will get us 34. How would I solve this? How would I get x by itself? Yeah, divide by 50. So do it. Grab your calculator. Do 34 divided by 50. And x gets a decimal 6.8. And then how do I turn that into a percent? Times it by 100. Farah's just going to take over class and start teaching for me, it sounds like. So that means our sale, like what we're paying, this percent right over here is 68%. Meaning what we saved was 32%. We just saved 32% thanks to whatever sale is going on. So you guys, we've done a ton with proportions this year. But we've also been practicing algebra and solving equations. This is what's in your math notes. The percent change times the original amount. So what we just did, if you want to copy it in your math notes, except here, they say amount of increase or decrease. So guys, there's another way we can do this. Watch. Actually, for a second, put your pencil down. I want you to just watch. The first thing that we figured out through subtraction was $16 was the amount of change. Right? So if I set up 16 is equal to my percent that I don't know times the original. Guys, here's what's going to mess you up. If this is what we don't know, and you write x times something, like x times 50, most people, hey, don't, you should not be copying really. Most people are going to get confused by this. Most people are not going to be able to as quickly say what to do than if we write 50 times x. So my advice is always put the number in front of the x, even though it's the same thing as x times 50. 50 times x makes more sense to us, because then in our brain we say, what do we do to get x by itself? Exactly what Farah's been telling us to do. Divide by 50. So grab a calculator, do 16 divided by 50. See what we get. And that is our 32%. So then we just found the other percent, right, from our model up here. If we take the $16 and calculate that way, we find 32%. My orange doesn't show up very well. So what that means is 32% off. Or, what percent did we say was on? 68. Questions? I gotta check what I'm wanting to do next. We're unable to Desmos or anything right now because the internet's out. Alright, so if actually Antonella and I were talking about like sweatshirt prices earlier. If I have you increase, so this is going to be on your graph paper, I mean, unless you want to squeeze it onto your lesson paper, but this is not a problem on there. If I have you increase from $30 to $33, what is the percent change there? If we're going from 30 to 33, how much are we increasing by dollar-wise? $3. So guys, here's another. Now, if you ask your parents or your siblings, some people are just going to straight up tell you when you're looking at a percent problem, and this is true, that percent equals part divided by whole times 100. And that is true. But here's where that comes from. If we're going to increase by $3, and we're saying, what is that as a percent? What I'm actually doing is 3 compared to, what did my price start at? 30. Change over original is really what we're doing. Write this down if you don't have it written down yet. So our part here in this problem is really change. And then whole is really original. So I think what we're going to be able to say, so I'm going to write this a little cleaner because I'm going to make some space for it. What we can say is percent change. Percent change. You should write this down. Percent change can equal the change over the original. And that times 100. And guys, you can put that on your math notes paper too. That would be really convenient. That could go right here. That is actually what they're doing with this equation. Percent But then we got to do the times 100 to move that decimal point. All right, well, if we go back to the problem that we were looking at then, what's 3 divided by 30? 0.1, right? If I do 3 divided by 30, we get 0.1. But that's not our percent. Because what do I have to do to the 0.1? Multiply by 100. So really I need to add another extra 0 to multiply by 100. What percent is it? 10% increase, right? They increased their price 10% up. But what if the next week we decide, oh crap, that was a bad idea. I should bring that price back down. So now, instead of going from $30 to $33, we're reversing this. Or we're saying, I'm actually going to drop the price from 33 down to 30. Talk with your team about how this one's different. It is not the same answer. This is different. Talk with your team. What's the trap door? Take like a minute or two. We'll do that, and then we'll get you guys out of here. Numbers, you are right. It is numbers. That's how it's different. Are we going up or down here? Down. How much are we going down by? Minusing $3. But what was the original? Now the original is 33. So that is going to change the denominator. We're not going to use 30 for this problem. Now we're going to use 33 for the original. So it's still a change of 3. Change of 3. But the original, the price we came from, was 33. That's how this part is different. The denominator is what we came from. It's what we call the original. So this is 0.09. When we put that in the calculator, I think, right? Can somebody check that? 3 divided by 33? Yeah, it keeps going, right? So then we times 100, and we're just going to have to round. So times 100, and we get 9-ish percent. We could say like 9.1, but like 9-ish percent. And we would say decrease, right? Like 9% decrease. This up here was a 10% increase. 9% because the denominator changed. So, guys, give me your eyes, because some of you just don't care right now, and Aiden's the one saying, like, wait, what? Like, why? Going from 30 to 33, right? Sorry, I covered some of it up. Going from 30 to 33, that was 10% up. But then, when we turned it around and came back down, it's not the same percent. It's different because now the price we're coming from is a bigger denominator, right? The denominator of 30 versus the denominator of 33. This is what changed. So the price you started at, that's what makes this different than that. We can talk more about this another time. I still got like a minute or two, so I need to pass out papers to some people. So really just come up here if I call you. Aiden, Lucas, Layla, Isabella. Graf, sorry. Actually, both. Franco, Aiden. Laura, John, Eve, Mia, pretty much anyone who turned work in. Layla Graff again. Lucas again. Oops, right there. Lucas again. There's you. Vanessa, Franco, another Mia, another Laura. Franco, Laura. Leo Davis again. Mia, Eli, John. Can I have a no name? You're gonna need to put your name on that and turn it back in. I got a no name over there as well for 713, I think it is. So if you think you turned that in and didn't get it back, Eli, Eve, John, Aiden, and Layla Davis. And then it is time to get out of here. Layla, Aiden, Layla. Thank you. All right, have a wonderful day, guys. Was that you? Awesome. Put your name on it. Turn it back in.